Corporate real estate is saturated with talk of ESG, environmental, social, and governance. But look past the polished boardroom presentations and the marketing plaques, and you'll usually find an excavator sinking into deep mud. When the conventional industry tries to add density, they run their sites on what we call organized chaos. They rely on heroic site starts, mobilizing based on assumptions, and hoping to figure out the critical details on the fly. That guesswork has a direct environmental cost. Materials sit in the mud and get ruined. Trades drive back and forth to the site 5 times because the sequencing is wrong. Rework and delay translate directly into carbon emissions. Real sustainability isn't found in a brochure. It's delivered through durable assets that are quiet, efficient, and built without waste. Achieving that requires moving past marketing and into strict mathematical proof. To see what that proof looks like, let's set up a control group. Take a typical older Toronto property. Let's call it 5 Knight Street, housing exactly 2 people. We measure its footprint using EnerGuide, the official government energy rating system used in Canada, to strip away any marketing subjectivity. This chart plots the raw consumption data. The benchmark for a typical new house sits at 62 gigajoules, a gigajoule being a standard unit of energy equal to about 2 barbecue propane tanks. 5 Knight Street burns through 142 gigajoules annually. That level of energy use has a severe environmental consequence, pushing the property to emit 6.1 tons of greenhouse gas every single year. When you divide that output by the 2 residents living there, the core problem becomes clear. Housing 2 people here results in a carbon footprint of over 3 tons per person. Solving this requires abandoning traditional building methods entirely. Instead, we move to an industrialized manufacturing pipeline designed specifically for the missing middle. Highly efficient multi-unit buildings, typically between 6 and 20 units, that bridge the gap between single-family homes and massive towers. We execute this using the REBUS framework, which stands for Rule-Based Engineering System. It treats construction like a high-precision factory rather than a custom craft project. This schematic shows how the system operates through 7 non-negotiable verification gates, CP0 through CP6. Look closely at the first gate, CP1, design freeze. Here, the architectural plan and financial budget are 100% locked before a single shovel hits the dirt. Strict factory discipline is a primary ESG lever because it prevents the carbon-heavy friction of drywall waste, rework, and machinery idling. By enforcing absolute verification at each checkpoint, we eliminate the operational friction that drives up a building's carbon costs during construction. We can see the physical result of this intervention at 50 Castleton Avenue, transforming a standard residential lot into a high-performance multi-unit building. The utility of the land has multiplied. The exact same lot footprint that previously housed 2 people now comfortably accommodates up to 20 residents. To validate our performance claims, we ran a new, verified EnerGuide evaluation on the completed property. This pie chart maps the post-construction energy profile, showing a highly controlled distribution where 28% goes to lights and appliances and 24% goes to water heating. Even with 20 people living inside, the net total energy consumption drops to just 27 gigajoules. We achieved this by engineering in 101 gigajoules of on-site renewable energy. That massive reduction in net energy usage drops the building's total annual greenhouse gas emissions to 0.3 tons. It establishes a clear reality. You can exponentially multiply a neighborhood's housing density without multiplying its total carbon footprint. Let's run the numbers. The control property emits 6.1 tons. The Castleton property, just 0.3 tons. Dividing the control's emissions by 2 residents yields 3,000 kilograms per person. Dividing the new building's footprint across 18 residents yields barely 15 kilograms per person. We achieved a 10-fold increase in housing density on the exact same plot of land, driving a 99% reduction in per capita carbon emissions. When you combine this efficiency with uncompromised acoustic privacy and a 10-year performance warranty, you move past marketing. This is the math of dignity. Housing that is durable, quiet, and affordable to operate, proven by verified data.